Well, good day and welcome to episode 27 of The Driving Force, presented by the Louisiana Transportation Research Center. My name is Todd Blunt, and I am flying solo today. My friend, colleague, and co-host Garrett Wheat, unfortunately not able to be here, but I am thrilled that you've chosen to join us as we highlight the people and the projects that are driving change here in Louisiana transportation. For nearly 40 years now, LTRC has been merging the resources of state government and Louisiana's great universities to identify, develop, and implement new technology to enhance many critical aspects of the transportation system here in Louisiana and beyond. And we've highlighted this several times throughout our first year of the show, but we work very closely with our friends and partners at Louisiana's DOTD headquarters to serve the state's citizens, the traveling public, in many different ways. So in today's episode, we're thrilled to wrap up a two-part mini-series with several members of DOTD's Pavement and Geotechnical Design section. On our last episode, we focused on pavement design, and today we'll jump into the geotechnical side of the equation. Once again, we are welcoming back section head Chris Nickel, along with two of our talented geotechnical engineers, Jesse Rauser and Miranda Perkins. So we'll take a quick break before we dive into today's conversation. Well, welcome back to The Driving Force. Today is the second in a two-part mini-series with DOTD's Pavement and Geotechnical Design section. As we said before the break, we're excited to have Chris Nickel, Jesse Rauser, and Miranda Perkins joining us to share about what they do and how it impacts road users across Louisiana every day. So welcome to all of you. We begin every episode with introductions. This one's no exception. So I'd like each of you to start by telling our listeners just a little bit about yourselves and how your education and career background led you to where you are now. Chris, why don't we start with you?
Okay. Well, thank you for having us today. So I'll start with, I went to McNeese State, so that's where I went to college. And in my time there, while I was there, I actually, as a summer student worker, I worked a few summers in the Sulphur construction office.
Okay.
So got to see a lot of construction stuff going on that side of the state. But through my time, actually one summer or two, I worked with Bow Brothers Construction, so I've seen a lot of construction stuff during my time while I was at school. After that, they had a career fair on campus,
okay.
And so I went. DOTD had some representatives there, so I went and met with them and talked to them, and that's when they first told me about the rotation program.
Yeah.
And I was like, hey, that sounds pretty cool. So that was something I was wanting to do. So after I graduated, I joined LTRC through the rotation program through DOTD, and I did the entire 14-month program at the time. Not many people completely finished it, but I did at the time. They really encouraged completing the whole rotation. And during the time, I was thinking I was really going to go into construction. That's something I really like doing. My dad worked for DOTD, and he was in the construction area with DOTD also. So, but going through the rotation, as I rotated through the different sections, I got to the geotechnical group. And so I really liked it, enjoyed it. I liked the aspect of being able to do engineering and doing your design in the office, and also getting out, seeing it built and constructed and monitor what you design. It was really cool. So I like doing that. So I was like, hey, I want to stay here. So, and fortunately they had a spot, and I joined the Pavement Geotechnical section, and I've been there ever since. And I kind of stayed in the geotechnical area the whole time, worked my way up over the years, and I've been in this position as the administrator for almost 8 years now.
Okay.
So.
How many years total with the section?
So total years, I've been over 27 years now.
Wow.
So I've been here like the entire time.
So you've seen some stuff.
Yeah, sure have. Yep. So that's pretty much my story.
Awesome. Miranda, how about you?
So I graduated from LSU with a civil engineering degree back in December of 2015. And after graduation, I went and worked for a private firm for about a year before deciding to try something different. And that's when I came to DOTD through LTRC's rotation program as well.
Awesome.
I did the rotation for a brief stint, not nearly as long as Chris did. And once I got to the geotech section, I really enjoyed it. I thought it was a really good blend of design in the office, but also getting out and getting some construction experience as well So I actually got off rotation early and took one of the empty positions they had in the geotech section.
Awesome.
And I've been there since.
Jesse?
Let's see. I finished my undergrad at LSU in 2003. Leading up to graduation, I really wanted to do traffic. I guess anyone that's taken a class with Dr. Walshaw knows he's very enthusiastic about what he does, and that kind of bled over into me, and then it came down to trying to find a job, and geotech was the one I could find. And I was out of school for 6 months, and my boss said, why don't you think about taking some more classes? So I went back and got a master's in geotech at LSU, wrapped that up in 2008. And, in retrospect, I can't imagine doing anything different. At the time, I wanted to do traffic so bad, and now I'm like, geotech is it's really where it's at for me. So I worked for a little company called Soil Testing Engineers that was later bought out by Arteman and Associates for about 8 years, and then I had an opportunity to come work for the state. So Chris and let's see who else. Derek was in the section at the time. So we had a couple people in the section I already had a relationship with because, in the consulting world, DOTD was probably my best client. Mm-hmm. And having kind of built that relationship, I found out about an opening and decided to come interview and ended up over here at DOTD, and I've been here now for 14 and a half years. That's pretty much my story, too.
Yeah. One of the things we talked about before we started recording, because I noted this on our Pavement episode last time, was how much continuity and longevity there is within this section, and I think that's got to be great not only for rapport but just for effectiveness and sort of knowing how each other think and work and just doing really great things for the state, having been together for so long.
I think too, like the rotation program, I know Jesse didn't, he has a different story, but a lot of the guys in there, probably half came off the rotation program.
Yeah, that's awesome. Well, Chris, on our last episode, you provided an overview of the pavement design unit's responsibilities. Can you do the same for the geotechnical design group now?
Sure, yeah. So the geotechnical side of things, it's also a relatively kind of small group. It's about, I think it's around 10 engineers that we have.
Okay.
And they're responsible for all the geotechnical design requests that come in statewide. I know we do most of the engineering in-house. Some of it's outsourced, but a good portion of it, 80% or so, is done in-house. Most of the design is foundation designs, deep foundation stuff, driven piles.
Yep.
They could be concrete. For the most part, is a lot of what we use. Some steel piles and timber piles are used occasionally. Also drill shafts, that's another type of foundation.
Okay.
I don't know how familiar people are with that, but basically they excavate a shaft in the ground, they put the reinforcing steel in there and put concrete in. You have your deep foundation there, and that's different from, driving the pile in the ground. Some of the other designs that we're responsible for is earth retaining structures.
Okay.
Some of your retaining walls that you see out there, concrete cantilever walls. Typically, you may see these around bridge ends and things like that. Mechanically stabilized earth walls, that's the block type, panel type walls that you see around. And there's also, it can be steel sheet piling, can also be used to retain soil.
Okay.
And so this retained soil, there's also embankment stability, roadway embankments. A lot of the fill that's put out there has to be analyzed to make sure that the embankment is stable, that the slopes will be stable. Also, settlement analysis also comes into play. You stack that embankment out there, and it can tend to, if you have weaker, softer layers underneath, cause some settlement. You can get that bump at the end of the bridge, so we try to mitigate that. Other aspects too is, like I said, the construction support. So we also go out, like I said, we do a lot of the deep foundations, the driven piles, which we monitor those piles with our pile driving analyzer. Basically, it's a fancy computer we can take out there and hook up gauges to the pile and actually monitor the stresses and keep an eye on the integrity of the pile. Drill shafts would do something a little different. When those concrete's cast in there, there are also tubes that are cast in there that we can use some sonic logging that sends a wave through the concrete to kind of check the integrity of the concrete, make sure the concrete's curing properly and that there's no voids or anomalies in the concrete. And there's another method which we also use, the thermal integrity testing of the concrete, which basically it measures through the heat of hydration of the concrete to determine whether or not that concrete's going to be sound and that you're not going to have any anomalies and issues with that. So we get out there. So we also see some called out slope repair issues that come up from time to time. They may have some problems with the embankments kind of, sloughing off, failing a little bit, and they want to get our input on that. Settlement data we look at too that comes in from construction and things like that. So there's a lot of different things that we're involved with in construction too. So that's a pretty good portion of what our workload is also. Like I said, we do have consultant contracts. Most of those contracts are used to perform our subsurface investigation, our deep soil borings, the data, the soil information that we need to perform the design analysis. And 90+% of all that is done through our contracts. Some engineering, but not as much. And so I think we have 8 or 9 consultants on board and maybe 10 contracts.
Yeah.
So that's basically it in a nutshell.
Sounds like a nice mix of field work and I guess intra-office design type work. You said that's one of the things that you really enjoy about this particular section is that you get to kind of see the process a little bit from beginning to end and even maintenance and monitoring afterward.
It's really neat because you go through the design phase and that may take, it takes a long time. It could be a year or so. And then when it gets constructed, that takes another couple of years so that you get to see the entire process.
Yeah.
It's pretty neat, yeah.
Jesse, hopping over to you now. Can you explain the differences between some of the different structures that Chris just described to as foundations, walls, embankments? What are some of the common use cases for these structures and these components that you guys design and monitor?
Sure. So, at a really high level, and I'll come back to each one, but at a really high level, if you have a deep foundation, it's because you need to put something on top of it.
Yep.
If you have a wall, it's because you need to hold something back. And if you have an embankment, it's because you need to lift something up.
That's a good way to explain it.
And that's the high level. But obviously, in Louisiana, we have soils that were a large part of the state were deposited by the Mississippi River and the Atchafalaya rivers, and so they're geologically speaking pretty soft. So we don't have the luxury of being able to build something on the ground like a shallow footing, or maybe driving some shallow 10-20 foot piles to bedrock. We don't see bedrock in this state. So a lot of what we do is by virtue of the soft soils that we have, we put a lot of things on deep foundations. So the drilled shafts and the driven piles that Chris talks about, that's our bread and butter. Okay. For the most part, anything we do is going to probably be on one of those two types of foundations for the most part. One of the other issues we deal with is scour. So in other words, we have to design assuming that some massive flood event is potentially going to come through and maybe make the bottom of the channel 20 feet deeper at some point in the future than it is right now. Okay. So we have to contend with that potential changing kind of landscape of the project, and deep foundations helps us to do that too, because if you put something on what you think is solid ground right now, it may not be that way in the future.
Yeah.
So deep foundations certainly is how we deal with soft soils and scour and high load combinations. Walls, we use those for different reasons, but mainly, if we're going to use a wall, it's because we don't have the right of way to build a slope. So, we can stack earth and fill fairly stable at a 3-to-1 slope or 4-to-1 or 5-to-1 slope, but you can imagine if you need 10 foot of elevation on a 3-to-1 slope, you need 30 feet off to the
You
side.
need a good bit of space.
So definitely in urban environments and things where we just don't have the right of way, we build walls. And that's more of a right of way issue where we don't have the luxury of just going crazy with embankment. Embankment, if we need to raise something up and we have the room to do it, we'll typically place fill and slope it on the sides. And we're a fairly flat state, so there's not a lot of cut sections in our state. If you drive somewhere with a lot of relief, you'll see cut sections where they'll literally cut the side of a mountain or something and build a road alongside it. We don't do that. So most of our fill is to get over the top of something. So if we need to build an overpass or a bridge approach or something like that. So that's typically where you'll see the embankments. And then if you want to get complex about it, as Chris was saying, as you start stacking up fill and embankments, things can settle, things can have stability issues. So, probably the culmination of all this is if we put embankments on top of deep foundations, and we do some of that too. So, there's different ways to skin the cat, and we combine these solutions and some of the people probably don't realize it, but there's a lot that goes into those decisions in terms of how much does it cost, what are we technically limited, and then in terms of just construction, can we even phase this? Can somebody even physically build this thing?
Yeah.
So there's a lot of implications in terms of how these things are going to be put in the ground as to what we might select to do, and sometimes it comes down to how much time we have.
Yeah.
But that's kind of the high level overview of what we do with those structures.
Okay, so give me and give our listeners a sense. When you talk about deep foundations, driven piles, drill shaft, like how deep? How deep are we going here?
I would say on
and I know it varies, but
it absolutely varies, and we might have 80-foot piles on a smaller bridge, but if we're building larger structures down near the coast, we've exceeded 200 feet on some of our piles. I think I've got a project right now where at least one of the pile order lengths, I think it's a 30-inch square concrete pile, and it's over 200 feet.
That's wild.
Yeah, so we're dealing with very unique soils, and most people in other states drive piles, but you're not going to see piles that deep unless you're going offshore or something like that. So,
Miranda, we've mentioned not only construction but also monitoring. So talk to us about some of the work that you guys do, monitoring foundations, monitoring settlement on some of these structures. Kind of what does that work look like on an ongoing basis around the state?
Yeah, so let's start with foundations first. Chris kind of touched on it when he mentioned the pile driving analyzer or a PDA.
Okay.
But what that means is we'll go out before the contractor drives a pile and we'll attach two sets of gauges. We set a strain gauge and a set of accelerometers onto the pile. Then while those are attached, the contractor will actually be driving their pile. And as they're doing that in real time, we can be monitoring driving stresses. We can get an idea of capacity of the pile from driving. And we can even monitor if potential damages have occurred while they've been driving.
Okay.
And we do that pretty much all in-house. Not necessarily every project will require that. It depends on whatever design assumptions that the engineer made during design. But we probably have a group, I'd say once a week, out there monitoring piles somewhere on our projects. For settlement, it is much less sophisticated. Typically, when we're talking about a settlement, we're talking about monitoring embankments for settlements, as Jesse kind of touched on. And what we do for that is the contractor will set a rod before they replace any of their embankment on whatever natural ground is there, and then they can start placing their fill. And all the contractor are doing is they shoot that top of the rod periodically. And from that data, we can plot it out and compare it to what we estimated our settlement to look like to kind of get an idea if we can halt the settlement period, if we need to extend the settlement period, and kind of let the contractor know when they can start their construction.
Okay. So you're just monitoring that over time, literally just taking I guess like an elevation. I don't know.
Yeah, they're just shooting
using
elevation.
a technically correct term. Yeah. Mm-hmm. Gotcha. What are some other tools and techniques you guys use in your various work around the state?
One of the cool tools we're using right now is not necessarily new technology, but the CPT, which is the cone penetration test.
Yeah, I've read about that.
LTRC's done a lot of research to help us just continue to use it in different ways or to maybe better refine things. Recently, LTRC completed a project that gave us a new software to use for pile design. So we use the CPT pretty heavily. It has its benefits that they're typically cheaper than borings, they're quicker than borings. They're not necessarily a direct replacement, but they can use to supplement that data, or especially to get some of that early while we're waiting for boring so we can even start on a preliminary design. Another tool that we're just now kind of starting to use is electrical resistivity. What that is we set stakes in a line along a surface and we pass an electrical current through it.
Okay.
And as each stake picks that up, from that we can determine, kind of get an idea of like what kind of soil we're talking about is there, potentially see even obstructions even that we may not have missed, or we may have missed rather, from just doing our typical boring. So that's probably two of the newer tools.
Yeah,
we're
I think our team here at LTRC, I've seen them testing some of the electric resistivity stuff outside. I'll see them drive stakes and be running things down. So that must be what they're doing. Yeah, very cool. Jesse, going back to foundations and some of the different materials used for structures in the state, what are the factors that determine what materials you might use on a given project? And kind of as a follow-up to that, what are some of the unique things about Louisiana's soils and topography that require maybe a different approach than some surrounding states?
Most of our piles are pre-stressed concrete piles, and the reason for that is they undergo serious tensile stresses when we drive them. So concrete doesn't have much of a tensile strength at all. So you've got to pre-stress these piles with steel to basically hold them together while you drive them. So in terms of, there's a lot of states that use steel. It's a lot more resilient towards tensile stresses or even compressive stresses during driving. But we've got to be a lot more careful with our concrete piles. And we do some timber piles. Obviously, those are limited by the size of the tree. You're not going to drive a 200-foot timber pile. You might max out in the 60 some odd foot range.
Sure.
But they're great for certain applications. One thing we're kind of looking at, not necessarily as a replacement to piles, but we've tried to move to be more open-minded towards what's called ground improvement or ground modification technology, where there's a lot of people with proprietary ideas on that, but what it really boils down to is you replace the soil with a grid of something else. So you might go in with every 3 feet, every 5 feet, every whatever, and do a grid of a grouted column where you mix the soil with grout and you create a stronger material. So that's kind of an interesting way that we can reuse the soil that's there. And then in terms of our walls and embankments, because we have such soft soils and because we have things that settle and could potentially fail if the soil were to be piled high enough, we use a lot of lightweight material where, typical soil, you compact it in the ground, sitting on top of the ground, it's there at about 125 pounds per cubic foot, and we can reduce that by a factor of, 5, and it varies. You can get lightweight aggregate heavier than water. You can get some that's so light it floats on water.
Wow.
And so it just depends on what the application is, but we will engineer our embankments with lightweight aggregate to either minimize the amount of settlement that we're going to see, or to minimize the load, where we can either go higher with it or put it in a place where we normally wouldn't be able to put fill because it would either sink or fail. And so we there's some innovation in terms of lighter weight materials and replacing the soil with better mixed materials that we do. So
I think it's probably safe to say that one of the main things you're combating in everything is the moisture, right? Just the really wet soils we have here, soft soils we have here.
And they're related sometimes. You can have a decent soil with a higher moisture content, but for the most part, we're dealing with soils that are either very soft or maybe they're not soft, but they do have a high moisture content, and therefore a higher potential for that moisture to squeeze out once you put something on top of it. So that volume will eventually be replaced by squeezing that water out, and you lose that void ratio, which is you densify the soil by putting the load on top of it, and all the water goes away, and that's how things settle. That's basically how it happens. So we're combating that for sure.
So I'll pitch this to any of you who want to jump in. All of you can jump in on this if you want, but any favorite or most memorable projects that come to mind? All of you have been at this for a few years now, but anything you want to highlight from your time with this unit?
I think everybody's probably got at least that one or two projects that you worked on your whole, during your career that's like very memorable. For me, it was the US 90 Wrigley's Pass Bridge, which connects Orleans Parish to St. Tammany.
Okay.
And those piles, I got to do the design on those piles and follow up and monitor them as well. And that was one of my first big projects. And, like Jesse said, some of these piles can be very long. And I know one of the indicator piles on there was 200 feet long. Now, these are 66-inch spun cast post-tension cylindrical piles. So these things are massive, so they're huge. So that was really cool to be able to design that, go out there, monitor these piles, also get, picked up in the man basket to go to the top of these piles and, attach the gauges and stuff like that for the pile driving and analyzing. And then during the middle of, we didn't get all the piles driven yet, Hurricane Katrina came through. This is about the same time. So about the time they finished that, we got to get our hands on some of the work on the I-10 twin span bridges too. So that's kind of my project.
I could see that.
I'll never forget working on. So
I could see that. Jesse, Miranda, anything y'all want to jump in with?
Yeah. So I've got a project I've been working on now for 23 years, something like that. Or it's going on 23. So when I graduated from school in 2003, within a month or two, my boss dropped me on an airboat in the middle of the marsh in Lafourche Parish, and we started getting soil samples for the LA1 relocated project. So that project eventually is going to connect Port Fouchon, which there's a very large Louisiana offshore oil platform or something like that is the name of it, and there's a big port down there, and the existing Highway 1 is basically at grade. In other words, during a storm surge event, it goes underwater.
Yeah.
And so the intent is to eventually replace almost 20 miles of that highway with elevated highway from the port all the way into the protection levee at Golden Meadow. And there's actually future plans to even do more. But what's tangible right now is, we're currently building the northern phase of the project to get us into that levee. So I was fortunate enough to literally pull the soil samples out of the ground, test the samples in our geotechnical laboratory at the office, oversee all of the PDA testing. I lived in a trailer on the site for several weeks at a time, and would come back and swap out with people. And then when I left that job, we were getting the soil borings and CPTs for phase 2, which in total, I think it exceeded like 400 exploration points. We had 360 something odd CPTs and almost 70 borings. And so I left in the middle of that, came over to the department, and was fortunately able to keep the design work for the second phase in-house at the department. And so I'm still working on it. and so we're building the second phase right now. There's a couple of years left in construction, but hopefully here in the next couple of years, we will have the entire elevated highway from Port Fouchon all the way to the protection levee, which, like I said, I've been working on it for almost a quarter of a century.
Big project.
And it's that's kind of my baby right now. I mean, I've got a lot of projects that I've really learned a lot, but that one literally has covered every possible thing. So,
Miranda, you got one?
Yeah. Mine was probably the first bridge that I just got to work on when I first joined the Geotech group. It was LA 16 over the Amite River Bridge in French Settlement. And what was cool about that one for me is at the very end of the bridges, there's about 13 feet of fill that they wanted to place on about 30 feet of just like muck. So we went to Bridge Design and we asked if we could lengthen the bridge because it was just not going to be able to put embankment here. And Bridge Design said that they wouldn't be able to because of the constraints that they had. So we had to come up with something cool. And from that, we did Louisiana's first geosynthetically reinforced load transfer platform. So we kind of touched on a little bit. I think Jesse mentioned it. But what that was is we drove a bunch of timber piles in a grid pattern and then alternated layers of stone and geogrid and to support our embankment. And it was Louisiana's first time ever doing that. LTRC instrumented it quite heavily for us. It worked really well, and from that, we've had opportunities to kind of work with FHGWA to refine the manual and the guidance that they give other states as well from our success. So that was really cool.
This bridge opened fairly recently,
Yes,
right?
it was in construction a really long time.
Yeah, I drove on this like a couple weeks ago for the first time since it opened. Yeah,
they finally did.
Awesome. Well, thank y'all so much for taking a few minutes out of what I know are your very busy schedules to join us on the show today. We love highlighting the broad and diverse functions of different department sections, seeing how each unique part fits within the big picture of our shared mission to serve our state's citizens. Before we go, we do want to have a little bit of fun with you, help our listeners get to know you a little bit personally as well. We have a couple lightning round questions for each of you. Don't think too hard about these. This is a surprise to you, and we'll have a good time with it. Chris, since we asked you a couple on the last episode, I just got one for you today, but you're going to go first. So what is the most unique or interesting place you've traveled, and what did you enjoy most about it?
I would say Canadian Rockies.
Oof.
Yeah,
That's
that was,
bucket list for
that
me.
was on our bucket list. We got to do that a couple of years ago. That traveled the Icefields Parkway between Banff, Lake Louise up to Jasper. Got to see Moraine Lake and all these. You can't go wrong. It's just surrounded by these mountains. It's awesome. So that's probably like our favorite, probably best trip. I highly recommend it if you ever get a chance to do that.
Yes,
It's really awesome.
I am actively envying you right now, but I bet that was an amazing trip. All right, so Jesse, we understand you're a musician. So tell us about any instruments you play and maybe a favorite or most memorable gig from the past few years.
I play guitar, I sing a little bit. I've been in a lot of different bands covering all kinds of stuff, from 80s hair metal to a Pink Floyd tribute band.
Fun.
I do a lot of acoustic shows at just little holes in the wall. And, I enjoy them all, but probably the most rewarding recent gig that I've done, we had a bass player in a band of mine. His name was Brian Moore, and he passed away recently. And so he was a huge impact on the music scene where I'm from in Lake Charles. And everybody knew the guy, but you didn't know the impact that he had until, so we did something called Be More Fest. And all the local bands basically donated their time to come play Be More Fest.
Yeah.
And people came out of the woodwork. And so to me, that was probably the most rewarding gig that I've played in a while, because it was like, hey, this guy was kind of my partner and my buddy. And to see literally everybody that I know in town come out to kind of celebrate, that was really cool.
That's
cool.
awesome.
Yeah.
All right, Miranda, hop over to you now. We are approaching the Christmas season. Do you have a favorite or a least favorite Christmas movie?
Ooh, that's a tough one. My least favorite is Christmas Story. I don't get it. I don't know why people love it so much.
I agree. I don't get it.
Yeah, I don't know. I have strong opinions about that movie.
My wife's family loves that movie. My family really does not like that movie, so it's a very divisive subject.
I've been to the house even.
Really?
Yeah, it's in Cleveland, Ohio. I've been to it, and I don't get it.
Okay. Do you have a favorite movie?
My favorite movie, I really like the new Grinch movie that they came out with. My kids really love it, so that's always been a fun one that our family likes to watch.
Awesome. One more for you, Miranda. Someone told us that you raise honeybees, which we found to be super interesting. So how did you get into this, and what's your favorite thing about doing it?
We got into it a couple of years ago after we purchased some land, so we had a little bit more space for it. my husband came home. He's like, I think we should try this. And I was like, let's just do it. So we have one hive right now, but we're actually hoping to get a second one in the spring.
Cool.
But my favorite thing, they're just such amazing animals. It's so cool what they do. It's also very low maintenance, so I don't have to work too much at them, which is also kind of nice.
That is really interesting. I love that. Well, thank you all again for your time and for everything you've shared with us today. Always so valuable to have these conversations and learn more about what our partners do and why it matters. We'll step away one more time before we put a bow on this episode, this series, in this first year of the Driving Force. Well, that's a wrap on episode 27 of The Driving Force, presented by the Louisiana Transportation Research Center. You can learn more about what's happening at LTRC on a daily basis by visiting us online at ltrc.lsu.edu or on social media through Facebook, X, LinkedIn, and YouTube. We encourage you to like, follow, and subscribe to our channels on each of these platforms. You can also learn more about the work that Chris, Jesse, Miranda, and their team are doing in geotechnical design by visiting their website, which we'll link to in today's show notes. We hope you'll join us next time as we begin year 2 of the Driving Force. We can't wait to continue sharing the great work happening across LTRC and DOTD and highlighting the difference that work makes in your everyday life as a member of the traveling public. We'll kick it off by welcoming special guest Dr. Vijay Gopu, LTRC's Associate Director of External Programs. He's going to tell us about the work that LTRC is partnering to do, not just around the state, not just around the nation, but around the world. Until then, I am your host, Todd Blunt, on behalf of Garrett Wheat, and we thank you so much again for joining us today. Drive safely out there.